Hello Algebra 2! This video is to help you with the Ecart review packet. Hopefully you've worked out several problems and just are watching this to watch your review to help you with your confusions. Feel free to fast forward or come back as you need to. I'm just going to work straight through all the problems and start with number 1. So as you go through the video, you can see where I am. If you need to start with number 6, just fast forward to there. The quiz will be next class, and you'll have all class to do the Ecart. All right, for number 1, the first thing that I notice is our directions here are talking about simplifying. So our whole section here with 1 through 5, they want us to simplify. So when they say that, in number 1, I'm looking at this exponent and thinking about what that means. And remember, that will mean that I'm going to write whatever is in the base, and in this case it's a pretty long base, that many times. So I'm going to go ahead and write down 3 minus 4 square root 3 times 3 minus 4 square root 3. So by simplify, in this case, we have to start by looking at the exponent. So now that I have a binomial times a binomial, I can either use FOIL or the box method. I'm going to go ahead and use FOIL. So remember what FOIL is. And we have first, and so 3 times 3 would be 9. And then outside would be 3 times negative 4 times the square root of 3. And remember, with radicals, we will multiply the coefficients and the radicand. So in this case, it's just negative 4 times 3 would be negative 12. And there's only one radicand, so square root 3. Our insides are the same so as the outside was, so it would be 3 times negative 4 would be negative 12, and then square root 3. And now for our last terms, we multiply our coefficients. Negative 4 times negative 4 would be positive 16, and then our radicands. Square root 3 times square root 3 would be 3 times 3 is 9, so square root 9. Now I'm going to combine like terms. These two are alike. So I'm going to add the coefficients just like we do with variables. If we have like radicands, you can only add them if they're alike. The index and the radicand has to be the same. So we have negative 24 square root 3. I'm going to go ahead and bring down the 9. Here, we are going to have a like term with the 9 after we simplify this radical. Remember that the square root of 9 would be 3, and 3 times 16 would be 48. Now we're going to add 48 and 9, and because they are like terms, so we have 57 and minus 24 square root 3. These two are not like terms, so we are finished. Okay, for number 2, remember our chart. We have I equals I squared equals negative 1, I cubed equals negative I, and then I to the 4th is equal to 1. Also remember, we can do this in the calculator as well. But first let's try it using our pattern. So anytime we see a multiple of 4, this pattern repeats every 4th time. So if this is a multiple of 4 and 72 is, right, we can divide, so 72 divided by 4 would be 18. So we could represent this power of 72 is 4 times 18, and then realize that I to the 4th is 1, so 1 to the 18th would be 1. The other way to do it is using the calculator, and whenever you have a problem with I, you want to make sure your mode is in real. So in this case, I mean in a complex mode. In this case, mine is not. So I need to set it from real to a plus bi. So you hit mode and then bring it down to where it says real and cross over to a plus bi and hit enter. Then we're going to, for I to the 72, that we have to hit math over to number and then down to Ipart. You hit Ipart, and now we're going to put I to the 72 inside this. So I is this above the period here in the blue, so we have to hit second I and then the caret and 72. And then we hit enter and the calculator gives us 1. So always make sure it makes sense to us whenever we use the calculator, but wanted to show you that as well. Okay, for number 3, we actually can do this in the calculator if you want to try that. Know that you'll see the negative here will distribute. We can put this whole thing in the calculator. I'm going to work it out by hand quickly and then show you the calculator. So 5 plus our square root of negative 40. We have our I, because negative 1 is going to turn to I, and then 4 times 10. Let's just talk about this part first. So if this negative square root of negative 1 becomes I, the square root of 4 becomes 2, and we'll leave 10 inside. And now let's think about the subtractions. We have a negative of a negative 2, so that would be plus 2, and then a minus. And here again we have, for square root of negative 4 would be negative 1 times 4, so the square root of negative 1 times 4, so that would be 2i. Our like terms here is 7, or 5 and 2, and then 2i square root 10 minus 2i. Now the only problem with using the calculator here is the calculator is going to round this and not give you the radical. So I'm actually not going to show you in the calculator this problem or this one, but if there's another one on the Ecart that is, let's say it was 5 plus the square root of negative 4, that we could do in the calculator. Let's just do this to simplify so that you can see what that would be. And we already have our calculator set in the I mode, in the A complex mode, so I can just start by typing in 5 plus, and then our square root of negative 4. And it's going to give you the complex mode of 5 plus 2i. So if it was a radicand, that won't simplify completely, and you guys know this from last unit, then it's not helpful to use a calculator. But if it will simplify, then it would help you to use the calculator to check. Okay? So for number 3, this is our final answer. These two are not like terms, and we wouldn't combine them. For number 4, we got to multiply here. And we're going to use first FOIL again. So 2 times 4 would be 8. Outside would be 2 times I square root 3. So plus 2i square root 3. Insides, we'd have 4 times negative 2 square root 2. So that would be negative 8i square root 2. And then last, we have negative 2i times I, which would be negative 2i squared. And square root 2 times square root 3 would be square root 6. And none of these are like terms, but I can simplify I squared. Remember, I squared is our negative 1. So we're going to plug that in. And -2 times -1 would make that +2 square root 6. Okay, so none of those are like terms, so we're done. We're simplified. In number 5, remember what this exponent is? We talked about it in the first problem. So our first step is x plus 7 times x plus 7. So that would be x squared would be the first terms, and then outside would be 7x. Inside, again, is 7x. And our last is 7 times 7 would be 49. So we combine like terms, x squared plus 14x plus 49. Okay. There's a typo in number 6. So take a look at number 6 and change this x to an m. So there's a typo there. So change x to m. Okay. All right, let's take a look at number 6. All right, number 6 says what is equivalent to the square root, the sixth root of 27m to the 18th. And I'm looking at my answer choices. Anytime you have multiple choice on the Ecart, that's a good strategy. Look at your answers and see which one would, if you can eliminate any, and also see where they're going. So in this case, in the top of my head, I can't think about what the sixth root of 27 is. I know 27 is a perfect cube, and interesting enough, that perfect cube they're using. So it looks like they want me to change 27 into exponential before I convert it. So this was radical, and this is exponential. But first, even before I convert it, I need to change 27. That's our perfect. It's a perfect cube, and it would be 3 cubed. Now it looks a little bit more like my answer choices. Now I just have to convert it. And remember, when we convert from radical to exponential, we put the exponent over the index, or the inside over the outside. So here we have 3 to the 3/6 power, and here we have m to the 18 over 6. And then we try to simplify. 3/6 simplifies to 1/2, and 18 divided by 6 is 2. So that was going to be equal to 3 to the 1/2, and 18 divided by 6 is 3. And there's our answer. Let's see if it matches up. Alright, it does match up to our first answer, and you can see the distractors are making sure you can reduce fractions and that you know that 27 is equal to 3 cubed. Okay, so A is your right answer. For 7, we have an inequality. For 8, we have an absolute value, and 9 we have a cube root, and it says to solve. I'm actually going to start with 8 since I'm about to approach the 15-minute limit. And remember that absolute value, what that means is the distance from 0. So this could be equal to +7, or it could be equal to -7, because the absolute value, whatever comes out of there, would be positive. So my first step, remember, is always to isolate the absolute value. The second step is to write 2 equations and solve, and the third is to check. Here it's always already isolated, so our 2 equations would be 1/2 x plus 5 equals 7, and 1/2 x plus 5 equals -7. So now we're going to solve for x and check. Go ahead and try that and bring it back. Okay, so when you solved, you got x equals 4 and x equals -24. And then you always want to go and check and make sure you didn't get extraneous solutions. So this worked out. So that would be it for number